Welcome back. Today our lesson is on square root functions and inequalities. We have a single learning target, and that is for you to be able to graph and to analyze both square root functions and square root inequalities. So first of all, square root functions. You're very familiar with quadratic functions. They graph as parabolas. And the inverse of a quadratic function is a square root equation. So we have this green graph here, it's a sideways parabola. It's only a function if we take the range and restrict it to positive numbers. So over here on the right, if we only use the positive values of x, then the inverse function is, or the inverse equation is a function. So on the left, where we have this equation, this is not a function, it doesn't pass the vertical line test. However, on the right-hand side, it is a function because we have restricted the domain. So when you see y equals the square root of x, remember we're just taking the primary square root, only the positive value. Otherwise, we're only taking both values if we have the plus or minus in front. So to graph a square root function, we need to find the values that make the radicand. The radicand is what's underneath the radical. So whatever makes that negative has to be excluded from the domain. Remember, the domain are the x values or the inputs. So let's take a look at a specific example so we can figure out what that looks like. So in this example, it says graph the function and state the domain, range, and the intercepts. So we want to start out by finding the values that'll make this radical or the radicand negative. So we're going to take whatever's under the radical and say that thing has to be positive, which means it has to be greater than or equal to 0. So when we go ahead and solve that thing for x, we subtract 4 from both sides and then divide by 3. X has to be all values greater than or equal to negative 4/3. This value gives us our x-intercept. So to go ahead and find out what the graph looks like, we need to pick values that are bigger than negative 4/3 or equal to negative 4/3. If we choose negative 4/3, we get 0. And then just choosing some other values that are bigger than negative 4/3, I picked negative 1, 0, and 4. If you put those in here and solve, these are the outputs that you get. And then if we go ahead and graph those ordered pairs, we get a graph that looks like this. So your x-intercept, negative 4/3, that's where it crosses the x-axis, and then plotting a few points there gives you the curve that you're looking for. Now if we look at our domain, our x values are nothing less than that negative 4/3. So our domain is anything for x that is greater than or equal to negative 4/3. The range is the y values. We don't have anything negative below the x-axis. So the range are all y values that are greater than or equal to 0. Here's a graphing calculator activity that I would like you to pause the video and do on your own. I want you to graph these three functions all at the same time. Be careful to, when you put in your square root of x, when you add +1 and -2 here, make sure that your parentheses are around just the square root of x when you put that function in. We want the 1 to be outside of the radical and the -2 outside of the radical. And I've given you a viewing window here. And then I've asked you a question. What does that do if we add 1 or subtract 2? What does that do to the graph? If this is your parent function, y equals the square root of x, what does this do to the graph? So describe that in your own words. And then here are three more functions, the parent function, and then multiplying by 2 and multiplying by 8 using the viewing window given. What does that do to the graph? And then lastly, make a conjecture. What do you think is going to happen? Or write an equation that translates the parent function, that graph, that square root function graph, to the left 3 units. How would we do that? What would that equation look like? And then check it out on your calculator and see if it works. So please complete these 3 questions and go on with the video when you're done with that and bring those answers to class. All right, graphing square root inequalities. Same as graphing square root functions that we were just doing. The only difference is now you're going to add shading and then the dotted or solid line boundaries. So here's an example. In this example, the first thing you're going to notice, it says y is less than the square root of 2x minus 6. So we need to graph this square root of 2x minus 6 function to see what that looks like. So we need to figure out what our domain values are going to be. So we set this to greater than or equal to 0, add 6, divide by 2, and we get x is greater than or equal to 3. So our domain is all values greater than or equal to 3. And then pick some values and plug them into the function. So I picked a couple of values here. I picked 3, and then anything bigger than that is a valid part of the domain. So I picked 5 and 7, and I figured out what those outputs would be. Then we want to go ahead and plot those points. Now we know since this says y is less than or equal to, less than the square root of 2x minus 6, this is going to be a dotted or a dashed boundary line. It's not going to be solid. So make sure to make that a dotted line, not solid. And then the shading, I've already shown you the shading here, but to determine whether it's shaded above or below, what we need to do is do a test point. Pick a point that's easy to work with, that's clearly either above or below your boundary line. I picked 4, 0. It's completely random. Make sure it's not something that's on the boundary line, but clearly above or below. You could pick 0, 0. That would work just as well. 4, 0, if I plug that into my function, I end up getting 0 less than the square root of 2, and the square root of 2 is about 1.4. So this is a true statement. So the 0.40 is part of the solution set, so I'm going to shade the side that contains 40. And that's about it for this video. So make sure you're able to come up with the charts, the ordered pairs of plotting points and getting those graphs, and we'll practice that in class. See you next time.